All right, this is the video lesson for graphing the quadratic in a real-world scenario. Quadratics, again, are polynomials. It's a second-degree polynomial, if you will, so it has x squared in it. And one thing polynomials do a really good job of is modeling what we call projectile motion. Basically, anytime you throw an object, you apply an initial force, and then you let gravity take over. The idea of what goes up must come down. So, for example, anytime you throw a ball, the quadratic equation is going to model its path in flight, ignoring factors like wind and air resistance. So, ignoring those, we're going to go ahead and look at the scenario here. A ball is thrown in the air from an initial height of 16 feet with an initial velocity of 96 feet per second. That initial velocity is its upward motion. Okay. There's also a component that goes horizontal, but we're focused on, for the formula, we're focused more on just the vertical motion here. The function that models this scenario is h of t. So the height as a function of time is equal to negative 16t squared plus 96t plus 16, where t represents the amount of time in seconds and from when it was thrown. And h of t obviously represents the height of the ball at any given time. So h of t equals to the height, and that's in feet. Okay? So we're going to graph the function using the table below. So as we talked about before, we're just going to come over and we're going to put this into our calculator. So now that we plug our equation into the calculator, we can go and we can do two things. But I think what we're first going to do is we're just going to pull over the data table. I'm going to go to second graph to give me my table. I'm going to have my values here. I'm going to adjust that just slightly as well, so I can get in my value for 6, and I'm even put in my value for 7 here. So we can see those values. Actually kind of do that. All right. So again, I see at negative 1, we have negative 96 feet. That would be somewhere under the ground. 16, 96, 144, 160. 144, 96, and 16. We see a pattern there, okay? All right. Our y-intercept, we already know our y-intercept is our initial value. It's also our c-value in standard form, so we get 0, 16. We don't see any zeros in the y column, so we're going to have to do second trace to find our x-intercepts. Let's go ahead and graph our points here. First of all, labeling our graph, we have time on the x-coordinate, height on the y-coordinate. Probably should label it height in feet, and time in seconds. Okay. Finding our value, 0, 16, that's going to be just short of 20. 196, almost short of 100. 2, 144, it's a little bit over here. 3, 160, so that matches perfectly. 4, 144, so about the same height as we were at 2 seconds. At 5 seconds, we're at 96. We're going to put it the same as where we were at 1 second. At 6 seconds, we're at 16 feet. And at 7 seconds, we're down at negative 96 feet. That's below the ground. I don't think this ball is going to penetrate the ground. Typically, that doesn't happen. So we can draw our graph here. And we see somewhere between 6 and 7 seconds, I'm going to have an x-intercept. And that'll be important. And sometime between 0 and negative 1 seconds, I would also have an x-intercept. If you could have negative time, which we really don't ever get into. All right. If we look at our graph here, one thing we're going to notice here is that 3 seconds, we're at 160 feet, and everything seems to be symmetrical around it. If we look at that graphically, 3, 160 is our maximum point, so that's our vertex, and it is a max. Our x-intercept then is going to be somewhere between 0 and 1 seconds. Means our left bound is negative 1, our right bound is going to be 0. And then our other x-intercept is between 6 and 7 seconds. We see at 6 seconds we're at 16 feet, at 7 seconds we're at negative 96 feet. At some point we're going to hit the ground and we're not going to go any further. That would be an impact, which is also an x-intercept. So our left bound is going to be 6. Our right bound is going to be 7. So now we're going to go to the calculator and calculate these out. I'm I'm going to show you the steps that I go through. You'll see the numbers highlight, or the keys highlight as I go through it. So I'm going to start with second trace. Option 2 is the 0 option. It's going to ask us for our left bound and right bound. Again, our first one will be at -1. That's our first left bound. Our right bound is at 2. Actually, it should be at 0. So I'm going to change that. My apologies. It should be at 0. So I have -1 and 0 is my right bound. I hit enter. I see that the intercept, this intercept right here, is between those two arrows. So I know I've done the right thing here. I hit enter for guess. And I find out my 0 is at -0.16 seconds, which of course is ridiculous because you're not going to have negative time, correct? All right, but we'll put it down there as it's negative, clear that up, -0.16, 0. That means at -16 seconds, I have a height of 0. Our other x-intercept now is, we know, is going to be between 6 and 7. So I'm going to erase that mark up there. I'm then going to go to second trace. Option number 2, which is 0s. My left bound now is going to be 6. Enter. My right bound is going to be 7. Enter. And I'm going to hit enter for my guess. And again, I see that this 0 is 6.16. So at 6.16 seconds, I'm going to have a height of 0, which means I've impacted. Okay? So this is when the ball hits the ground. And this is a non-real point. Because after all, I can't have negative time. Sometimes you get a value that's mathematically correct, but is not going to be practically correct. Other times you get a point that is mathematically correct, and it represents something as the ball hitting the ground. After all, that's when you hit 0 feet, you impact with the ground. All right, you should be able to do the word problem. That's at the end of your homework assignment. Good luck with that. Again, that homework assignment is due on Thursday evening, and best of luck for that.